talk about his work as an artist. So, you ready?
Yeah. Okay. So the talk tonight will be a hybrid between a screening and a talk. So I'm going to be speaking, but I'm also going to be silent for some time too. I'm going to be showing a lot of work, and I want to give you time to look at the work as well. So time for listening and time for looking. All the work that I'm going to be showing tonight is all live software. So it's software that's running on this computer, and none of it's pre-recorded, so it's not animation. It's all running. And some of the work that I'm going to show is software that's intended to be interactive, and so I'll be working with the software while I'm talking. And then other pieces of software are generative. And so in my software work, I make a distinction between things which are generative, meaning that they move on their own without any external input, and things which are interactive, meaning somehow some information from the environment, either a person or some other kind of information, is involved in changing the way the images unfold or animate in time. So this piece I have up now just as something to look at before I start talking, but I'm going to explain it more in depth at the beginning of the talk. So this is representative of the most recent work I've been doing. And the way that I work is I write software. So I spend a lot of time typing text, and then I run the software to produce images. And as I said, a lot of times I'm really actively engaged in changing how the software is making the images while it's running. And so the work that I produce is visual in the end, but in order to get to the visual result, there's always a lot of numerical results in between. And so I consider myself not to be an artist who makes software, or an artist who makes prints, or an artist who makes installations, but more generally an artist who develops processes. And so all the works that I create are sets of simple rules and simple elements that engage with each other, they interact with each other in time, and these larger structures emerge from these simple processes. And so in the course of working, numbers are generated that then become images. But for me, the numbers aren't important at all, but what's important is the way the numbers change over time. So it's the way that things, instead of a still image, it's the way that one image relates to another and the way that the motion happens. So a lot of my work is spending a lot of time working on the qualities of motion and the qualities of response, response being the primary thing behind interactions. So this talk's in 3 parts. This part I gave last night. So the first part, we're going to talk about a project I did for over 2 years called Vehicles. And then a project that is most recent, this idea of working with these processes, these emergent processes. And so with the Vehicles work, I used a book called Vehicles, written by a scientist called Valentino Breitenberg. And Valentino Breitenberg is a neuroanatomist, meaning that he spent his life studying the anatomy of nervous systems. And this book, Vehicles, was written in the early 1980s when he was an older man. And it's basically an encapsulation of his knowledge about nervous systems made into these really simple abstract systems. So over the course of the book, I think this is Vehicle 2. Over the course of the book, he describes these series of different vehicles and how they operate. And so these are read such as this is the sensor, and this is a motor, and then you have a connection between the sensor and the motor. And so you have these different physical configurations. So here they're a straight through, here they're crossed, and they're a little bit of both. And the basic idea here is that you have these different physical configurations which create different behavior. For the same way that nervous systems are different physical configurations that cause different behavior. And so these vehicles work in such a way where, for example, if these are sensors that are sensitive to light, and there's a light in the space, then if it's a straight through connection, then it moves towards the light. And if it's a cross connection, then it moves away from the light. So this slide just really simply shows how the configuration of the bodies of the vehicles change their behavior. And so I spent a lot of time putting this into software. This is more of an abstract diagrammatic representation, and so I made it a little more concrete in software. And so each one of these is one of the vehicles. You can see its sensors here in its body. And these yellow dots that are on the screen up there are the light elements, or they're what they're responding to. And so there's a few things you can see about the vehicles. And for me, this isn't a work. This is just like it's a sketch. It's a piece of process working towards something more. You can see they have different colors. And the different colors represent the different configurations of them. So if they have the straight connections or the cross connections, they all have a different color. So you can see, for example, the ones that are blue are kind of moving in the same way. The ones that are warm are moving in the same way. And over time, when I was working with this, I started thinking that rather than the positions of the vehicles being interesting, what's actually more interesting is instead the paths that they take while they're moving. So this is the same software we were looking at before, but now we're just looking at the way they move. And so every frame in the software, the position of each vehicle gets a dot. And so you can see the ones that are moving slowly make these lines that are more solid, and the ones that are moving quickly make lines that you can still read as lines, but they're just a series of points. And so the next step for me was to refine this visual representation and to figure out different ways of basically modifying the software while it was running, different ways of performing it. So I then developed this piece of software, which is called Tissue. And this is a version of that software. And here, each one of the lines represents the 30 previous positions of a vehicle. So you connect the dots together into a line. And then when I put a stimulus in the environment, you can see that they respond to it. And so then if I add another one, you can see that they respond differently still. And so as the environment changes, their behavior then shows based on how they respond to the environment. And so here, once again, there's a few different hues, a few different colors. And the colors are determined by the wiring of each of the vehicles. And so you can see that the green parts gradually start repeating themselves because those vehicles have the same wiring. And the grays start to follow a line because they have the same wiring. And so, for example, if I then move the points around, you can see that they respond differently. And so for me, this piece was about finding ways of pushing and pulling these elements on screen. So the larger forms that are emerging, sort of the circular elements and the linear elements that you see, I need one to bridge them, basically result from the way that each one of these individual elements is responding to the light elements, the yellow circles. And so I made a different version of this software that shows how this process is the same, but how making slight modifications to each vehicle makes different compositions. So that software is here. So in this case, once again, it's the same software, but there's a few different considerations made that cause it to grow in different ways. So in this one, we have a lot of lines, or a lot of vehicles, but each one is only looking at the last few steps that it takes. And so the images that resolve out of it are more fractured. And so here, for example, I can position the elements all at the same place, and they move towards this point where I just told them to go. And for me, one thing about this work, which I find interesting about it, is that I'm not able to control what's happening, but I'm able to sort of encourage different things to happen. So I'm not in control of precisely what's going on, but I'm able to kind of modify things and to push things in certain ways. So the range of compositions that can be developed out of this is, it's a really wide space to work within. So I'm going to switch to another representation here. And in this one, there are fewer vehicles, but they each have a longer period of time over which we're showing their movements. In this one, the relationship of the vehicles to the points is very different. And so in this particular one, they have a linear relationship between their distance to the points. And in the previous one, they had a nonlinear relationship, which causes them to make different compositions. In this one, once again, there's fewer elements, but we're looking at a longer period of time. And then in this one, they each have this slight randomness to their position at every frame. And so they move around and create these different looking forms. Hello. So in each of these cases, the core of the software is the same, but there's these slight modifications to their behavior that cause the composition to unfold in different ways. I think this last one's the most radical. And in this one, it's very similar to the piece that was showing before I started. And here, they have a tendency to move right. And so they move in these spirals and circles rather than moving along straight paths. And so the kind of compositions that result from this are distinct from the others. Okay, so that's that piece. So as a result of doing this work in software, I also developed a series of prints. And so the processes that I work with are the core of what I do, but I use them to develop printed images, software installations, sometimes performances, and sometimes more room or sculptural installations. In this case, this print was generated from the software. But whenever I do a series of prints from the software, I always modify the software heavily in order to get the most out of the printed medium. This is a close-up of that, a magnification. And then I did a series of four different prints for this series, and each one had slight changes to the way the vehicles were moving and working. And so the kinds of compositions that resulted from them were distinct. That's a close-up of that one. And then this is how the piece was installed. This was at the Bitforms Gallery in New York in 2001. And here are each of the print series. There were 5 on the wall in rows. And this interface at the front was running the software that I was showing you before. And so there were these small metal pieces here that you could move around. And by moving around the pieces of metal, you would determine what the environment was, where the yellow dots were positioned. And then the display was here. And this was the same, basically, software system that I developed for making all the prints. And so people that were visiting were able to see a range of different images that are possible to produce with the software. At the same time, they're able actually to use the software and to manipulate it in a live setting as well. So after working on this, I then took the same basic infrastructure to the software and developed this other series of images. And these are slightly different in the fact that instead of having a few thousand elements, for example, in the ones we were looking at before, there were around 2,000 different points moving. Here there's 200,000. And so the numbers have magnified tremendously. And as a result, the pieces are really more about shifting mass and texture and less about these linear movements. And this is a close-up of that printed image. There's a lot of color mixing here where there's only a few different basic hues for the lines, but they mix together optically due to the way it's printed. And in this case, as in the other cases, there's 4 basic colors in each image. And these images derive from the different wiring of the vehicles. And they have a property where if they're moving very quickly, they're at their pure hue. For example, maybe one of these brighter red colors. But as they start moving slowly, they move towards black, or they lose their saturation. I'm sorry, their brightness. And so you have these ranges of tones based on how fast they're moving and based on their wiring. And together they make these images. And once again, this is very much of a performance where I am manipulating the software while it's running. The software doesn't just run and produce images, but I'm always sort of working with it and modifying it while it runs. And then these images are the result of sometimes anywhere between 5 minutes to maybe an hour of working with the software. So these are a few different prints that were derived from that piece of software. And each one of these prints is around, I'll just say in inches, about 22 inches wide, because I have trouble converting to meters. And then based on the same software, I then developed a series of black and white prints. I was concerned about the color getting in the way of the forms that were being produced. So I tried a series in black and white, and this is meant to be shown as a triptych. And these images have an extremely high resolution. And so when we look at them, this is the actual resolution of the lines that you see here. It's not the size they are, but it's the same resolution. And then if we kind of zoom out, you can begin to see the composition emerging from that. So once again, these are produced the same way, by me moving around positions or dots on screen, and then generating still images from that. And yes. So this piece of software, then, that we were looking at before, is once again from the same basic algorithm, the same basic process, where we have each of these vehicles moving on screen, and then there are these different points that are moving around and controlling the way that the form transitions and moves to different states over time. So this piece, instead of being an interactive piece, is interactive. There's two pieces of software that are each communicating with each other, and the environment software is one set, which is always moving the points around on screen, and then each of the few thousand elements are then responding to the environment separately. So with a lot of the work, it's meant to be seen in motion. And usually when I exhibit the work, I exhibit the moving software with the static images as well, as ways of giving different perspectives on the same process. And another thing about the work which I find important is it's always changing, it's never static, and it's always moving to different states. And so if you leave and you come back in a half hour or 2 days, you'll always find it in a different place. And oftentimes, still for me, unexpected compositions emerge out of the way that these individual software components are responding to their environment. And then a question that I have, or I wonder about, is you were looking at this piece before, but now that I've explained for around 15 minutes what's behind the piece, do you perceive it in a different way, or does it change the way that you look at the work? Okay, so the next works are from the second series called Processes, and let's see what's there. When I started working on this new group of work, I really took a step back from what I'd been doing. I'd been programming really intensely, and I felt that I was starting to get constrained by the program notation. So I spent a lot of time basically typing into text editors and then producing the images from that. And I really wanted to get out of basically the code or the machine language that I was working with. In a lot of ways, I feel it's really constraining to work with the current generation of programming languages because they require you to be so precise about things. Like if I have an idea for a color or an image in my mind, I have to convert that into numbers, and then only after I do that can I see it back as a color on screen. And so I think really visually, but when I make computer programs, I have to translate my visual thinking into a linear representation, into a numeric and text-based representation before I can see it visually again. And so I started thinking about other ways of writing programs where I could have more flexibility and be more ambiguous. And I started looking instead of at the way engineers or the way computer scientists program, I started thinking more about the way possibly artists program. And so I started looking at art movements where instructions have been highly involved in those processes of making work. And so I did a lot of research into conceptual art, into the Fluxus movement, as a way of thinking about making instructions for making my processes. And so one artist that I spend a lot of time looking at is Saul LeWitt. And for his work, he writes these text-based instructions. For example, this is wall drawing number 146. And these are the instructions that generate this image. And in his working, he has these text instructions which are then executed by a human, by a person, a draft person. And so in my work, I write instructions which are then executed by this computer, or any computer. But in his work, he has text instructions that are executed by a person. And so doing that gives him a lot of flexibility and freedom. He can be ambiguous about things, he can be vague, and ambiguity and vagueness are things that I really enjoy and appreciate. And they're things that are taken away from me when I start writing computer code. And so I started then exploring different ways of writing my computer code with English text rather than with machine code first. And then an analogy to that can be made the way a composer sometimes works, where the final result of the composer is often a score. It's a notation that then is then interpreted by a person into a performance of the music. And so for me, I'm working now more in that way, where my final result for a work is then an instruction set which is meant to be interpreted by a person into machine code. So other artists that I started, well, I have to stop. Another thing about this work that I find really interesting is this idea of a separation of the execution from the idea. And so in Lewitt's work, you have the concept, or the instructions, and then separate from that, you have the execution. And so these two things are separated. And this is very much how it works with computer code, where I write a code, I write a software, and then it's then executed by the machine. So the separation exists there too. The same with music, where you have the score, which is then executed or run by the musician. And so other movements or other artists that I looked at, for example, are Yoko Ono, who did this a large series of instruction-based works. And then also California artist John Baldessari. His work's a different brand of conceptualism, but I still think his work is more humorous, but I still think it's applicable. So this is the name of the piece, and essentially this piece is a series of photographs that involve executing this instruction and documenting it. This is one of the more successful ones, but of course it's still not, doesn't really solve his goal. So this is how I'm working now. I write these processes, which are text-based codes, in English first, and the processes are developed from a series of elements, which are defined by forms and behaviors, and then the processes then are ways of determining how these elements work in an environment. And so if we just look at element 1, for example, element 1 is form 1 plus behavior 1 plus behavior 2 plus behavior 3. So form 1 is a circle. These are the behaviors: constant linear motion, constrained to the surface, and when touching another, change direction. So it's still a little bit rigid, but it's kind of a cross between English and something that would be executable by a computer. And so if we look at this in a really obvious or literal translation into code, this is what we get. And for the people who saw the talk last night, this looks really familiar. So here, each one of these is an instance of element 1. You can see that when they're moving along a straight line, they're moving straight, or when they're not touching another one, they're moving straight. When they overlap another one, you can see that they didn't change their angle. And you can also see that they're constrained to the surface, meaning that they never go outside of the bounds of this rectangle of the screen. So this is element 1 in its most literal. And then, so the way the work progresses is I have this basic library of forms and behaviors, which then compose elements. And then the processes are ways of composing the elements. And then from the processes, then I develop many different kinds of work. So this is basically a rigid structure that I work with. And it's my way of sort of integrating or developing these new processes that then I use in a more liberal way for doing other kinds of work. And so this is the process for in code, or after it's been executed in code running. And so this is a generative piece of software, meaning that it runs on its own. I don't change it. And so process 4, which this is running, is defined by lots of instances of element 1 moving into space. And when the two elements touch, they draw a line between their centers. So this is something that's also familiar from last night. And in this case, if the line that's made is short, it's black. But if the line is longer, it's white. And so lines in between are different variations on gray. So if we look at, this is the surface, but if we look at the engine that's behind it, it reveals what's actually happening. And so this is the machine behind that piece. So it's two ways of looking at the same process. So this is the surface that's created by it, and this is the infrastructure behind it. And so here you can see the lines that are being drawn when the two elements are touching, and you can also see their outlines. And so if I make a change to it, like for example, this is where some of the ambiguity comes into play. Some of the decisions that I need to make while I'm programming the piece. So for example, it says to put all the elements in the space, but doesn't really say how large to make them. And so I can have a really large difference between them. So a lot of there's small and some large. I can have them all the same size. I can have them mostly the same size. And depending on this choice that I make, it makes a different surface in the end. And so when I'm making the finished piece for this work, it's a lot about modulating the different values into a way where I find this frequency, or this sort of collection of different values that produces the image that I want to present as the work. And so one thing I like about the work is it's so variable and nearly infinite in the variations that are possible. And then I explore this possible space of variations and select the one that I want to show as the work. So if we look at another example, for example this, you can see this is another composition that emerges out of this process. So once again, from this work, I also developed a series of prints. And so this is one of the printed images from that process 4. And this image is about 1 meter by 1 meter. And if we look at it as a close-up, you can see that it has a different reading. And so looking at it from a distance, from my view, it has a bit of an organic feel, a little bit like some kinds of hair. But then when you look at it more closely, it looks more like fracturing light. It has a really different texture, different image to it. Now I'm going to go through a few examples that show different ways of looking at the same process. So once again, this is for process 4. And here we're looking at a different view, where this is more of a diagrammatic view of it. And then this is the data that's being produced by it. So I introduced this already earlier, but the idea is that each one of these, element 1, has an ID number, and you can see the ID numbers here. And it has a certain set of data associated with it. So it has an XY position, it has a radius, it has a rotation, and it also has the number of connections that it's currently making. And so this data and this image it's the same information, but it's just being presented in a different way. This is another representation of the same data. And so here, the connections between the elements are shown in red, and in this instance, this image, the elements are all much larger, and so there's more connections being made. This is how this piece was installed in the gallery, where you had the text description here, so the process was spelled out. And then here you have the software running. There's the computer. And then these were 2 images that were showing these different diagrams of the process. And this is yet a different way of looking at the process. This is ways of looking at the code structure. And so this image is the code itself. So the code is in these gray lines moving from left to right. And then these blue lines on top of it are the actual, the flow of the code. So it's the lines that are called after one another. So code is written is linear, but when it executes, it jumps around a lot. And so this just shows how the code is being run. And when you see an area like this, that's where we have a loop where a few hundred of those elements are all running the same process. And so the blue lines that we see here represent the first frame of that image being drawn. And so this shows more or less how the code is running and how the image is being produced from it. Or basically what lines of code are being read. And this is a close-up of that. And this is something I just made for fun. My background originally is in designing books. And so I love books very much. And so I produced this book from this code. And so what we see here is basically the binary executable in hexadecimal notation. And the book is about 30 pages long. And this is just one more way of looking at the code. So from process 4 then, I developed this performance. So this performance was about a year and a half ago at the Ars Electronica Festival. And this was in the Bruckner House. And let's see, this was a piece called Music for 18 Musicians by Steve Reich. And the orchestra here was playing the piece. Then I was over here to the side, and I was doing a live visual performance to the orchestra. And so I studied the score for a few weeks. I made a lot of visual notations for myself. And then for this particular piece of software then, I had these different patterns that I evolved over time, that I drew over time, to visualize the music as it was being played. So if we look at that software, when I was performing this piece live, I had a really large tablet, and I was basically drawing with my arm. Right now I'm drawing with my finger. So the kind of images that result are really different. But basically what I'm doing is the leading edge here is where I'm drawing. And the element 1, once again from process 4, when I draw, I'm just depositing that element onto the screen. And when I stop drawing, the elements remain and they continue to basically move around each other. So for different passages in the music, I developed different palettes and different ways of showing the images. For example, some parts had a more linear feel. So this particular piece of music is highly percussive and also highly repetitious. And so I chose this process because I felt that in many ways it represented the quality of the music very well. Before I got into writing software, drawing was an activity that I guess we have been doing my whole life and really enjoyed. And so a lot of the software work that I do relates to drawing in ways. Okay, so one more process. This is process 6. Process 6 is very similar to process 4, but it's different in the way the environment treats the elements. And so I can paraphrase this. To paraphrase it simply that if you have the rectangle full of elements, you have 3 points in that rectangle. All of the different circles, the different element 1, all emanate from they move out of one of those circles. And then when they reach the edge of that circle, they move back to the center again. And so this is how this process was shown in the gallery space, where here we had the process running, and these 2 series of images were then developed from that process. So here we see the software. So these are the 3 points that the pieces are moving from. And as the elements move out, they then, basically the lines are drawn between their centers as they move around on the screen. So I'll let this run for a minute or so. You're a very quiet audience. And you also don't really have any expressions on your faces either, so I can't tell what you're thinking. It's difficult. Okay, so this is a print based on process 6. And this is an enlargement of that print. And so each one of these small grid elements is one screen running with process 6. And they're all stopped at the 400th frame. And so it runs for 400 time steps, and then it's stopped. And each one of these has a different starting configuration. And so once again here, there are these, each one has 3 points at which the elements move out of. And in each one of these images, the 3 points are in a different position. And so for me, this print was about showing the variety of forms that can emerge out of this particular piece of software from different starting points. And for me, this piece is very much about this idea of growth. And when this work's running, there's no randomness to it at all. Everything moves in a totally determined way. But the only random element is the starting point of when the piece starts. And so everything that happens after these initial 6 numbers are selected are totally predetermined. This is another image from process 6. And this one's a little bit different in that I just ran one circle at a time and then composited everything after. And this is an enlargement of that. And so once again here, it's still those same circles moving around, still the lines being drawn from the circles, but here the visual representation is very different. In this case, this is really similar to the project that I was showing a lot yesterday, where you had the elements moving from the center and then drawing different colors. The colors here happen with different lengths of lines. So if the line's very short, it's white, and then it passes through this whole system of rules for the colors so that it moves basically through a gradation of colors. And the different colors are produced by layering on top of one another, but also by moving according to these rules of the length of the line being related to different colors. And this is an installation that I based on process 6. And so here, we had 19 different disks on the floor, and each one has a different image moving, projected onto it. Here you can see the space a little bit better, but the colors are quite off in this one. And so this was developed custom for this particular room, and this one shows the color a little bit better. One of the ideas with this piece was to take the work off of the screen, out of rectangles, and to move it into an environment to see how that changed the way people related to the piece. And so in this piece, people were basically moving around and looking at it, and all the images on the disks were kinetic. They were all software being run live. So we can look at, this is a grayscale version of what the software looked like while it was running on each of the disks. So it's very similar to what we've been looking at. So then one more of these, process 9. I showed this one because it's slightly different. So this one's dealing with a new element, element 2, which is just different because it has behavior 4, which says that after moving off the surface, enter from the opposite side. And so these aren't constrained to the edge anymore, but they move on and off the screen. And these elements are different because they draw circles at the points of contact. So this is the important line. Display the intersections by drawing a circle at each point of contact. So if you have 2 circles, when they overlap, it's just drawing a circle at each of the contact points. So this is the software that then corresponds to those instructions. I'm going to restart it. So these works are really intended to be looked at over a long period of time, and to really be, there's a lot of attention paid to extremely minor details, and oftentimes it takes quite a long time of looking at them before a lot of these details really reveal themselves. But I think for now I should stop it. Okay, whoops, that was the end actually. So I can just run this while if people have any questions.
When you think at this process, do you start from just from an hypothesis, a research idea, or in some way from an image, a sketch do you imaginate in some way? Do you research some image, or just research? It's just a research idea.
Both actually. Yeah, I'm not a conceptual artist, and so I don't have the concept, and then whatever results from that is fine. I'm quite a perceptual artist, meaning I put a lot of attention to the way things look, and so I work a lot back and forth from there. So things often start with a really simple idea based on geometry or based on behavior. So ways of orchestrating, for example, how a line might relate to a circle, or how one line might relate to another line. Or a simple behavior like when one line's on top of another line, have one change its direction. So things usually start at those really, really very simple, elemental, almost mechanical geometric place. And then I start working with it in software. And then as I start working with it in software, I do a lot of different sketches, a lot of different tests. And then maybe if I do like 15 different variations, I might pick one that I think this one's promising, and then I push it from there. And so it starts off with a really little bit of mechanics or a little bit of behavior, and then it really grows very fluidly from there in many different directions.
Okay. So in the end, you start from the software, from a concept. In the second time, you select the image you like most, the output image that you like most. In the second time.
Yeah, I think what I try and do with the output image is not just the one that I like the most, but I think the one for me that reveals the process in the most elegant way.
Yeah.
But things usually start with this idea of a process. So the way something relates to something else, and the way that these relationships can be changed or modified over a period of time.
Because my most important question is in a way something way living and every day you was fascinating something you see and trying to develop something that can be near and this thing that you see and that you have like.
I don't work that way actually. I don't try and simulate or mimic.
No, not simulate. Or
yep.
In many ways, living we're fascinating about something can be just like a street or many things. So in many ways, artists can start from these fascinating things, or sketch, or on paper. So
yeah.
This is not the way you.
No, I start off really bottom up, and then once some things start happening from the bottom up, then I work top down from there.
Yeah.
So I don't do as you were asking.
Okay, thank you.
But for me, one thing it's not important. This image that's produced is not what's important. it's really the way that this image that's produced relates to this piece of text that I wrote. Sort of the way they relate to one another, and the way people think differently about the image in response to the text and vice versa. It's about, for me, it's about these, this phenomena of having a simple process, then having these forms emerge from the way the process unfolds in time. That might not make any sense, but that's how I think of it.
My question was a bit of the same question, but put it another way. Do you often cheat? Do you often have a process that you've written and then you write the code, and the code deviates from the process so much that you have to go back and change the process that you wrote and say element something different and maybe add a behavior that you didn't have beforehand?
Yeah, I do that, but I don't consider it cheating.
Okay, what's code cheating?
Yeah, no, a lot of times I develop the software. I've developed the software to a certain degree of I develop the software and then I write the text after. I do that a lot, but I haven't yet made changes to the software to. Well, no, actually, oftentimes I write the text after I have the software, after I've been working with the software for a while, but I usually don't know what the text will do until I actually try it out. Because the way these things combine, they're not really very predictable. You can have a sense for what they do, and so, yeah, if I don't like what's happening, then I change the text.
Have you done the experiment of giving the text to your students and see if they produce a different code and a different set of images?
The way this whole thing started was this project that I did for the Whitney Museum in the United States. And it was this project, I'm trying to pull up the web browser, where I looked really, really closely, really didactically at LeWitt's work. And so in this project, I basically took some of his wall drawings and I implemented in software. And then I made modifications to them in software. And the idea for doing this was simply just to answer this question for me. Is what he was doing, can that in any way inform what I'm doing, or does it relate to what I do? And so I eventually sort of came to the conclusion that there are certain aspects of it that I think are really interesting in relation to what I do, and other aspects which are totally irrelevant. Let's see. I'm trying to show you something to illustrate the point, but it's not cooperating. So anyway, one of the first processes that I wrote was I then gave to, it was this one. This was before I sort of formalized the way that I was writing them into the elements and the behaviors. And so this process, a surface filled with 100 medium to small size circles. Each circle has a different size and direction, but moves at the same rate. Display the instantaneous intersections and display the aggregate intersections. I then gave to these three artists, Jared Tarbell, Robert Hodgen, and William Nguyen. And so this was the way that I interpreted the process. That's a good sign. It's an unfortunate image, but it's a good sign. So, I made an interpretation of the process, but I didn't show it to them, and they didn't communicate with each other. And then so we each made a software interpretation of this particular text. So this was mine. I think I should, That's much better.
While this is being drawn, did you also compare codes? Or just the images, the final?
Yeah, we compared codes too. But that was all in the end. And so everyone was given the text anonymously and independently, and everyone produced their images from it. And all that code's here. So this is Jared's. Jared's takes a while to get going. It's very sort of quiet. But this is the one that ended up being most similar to the one that I had made. And as a result of going through this exercise, the first thing that I realized is that there are many more variables into defining a piece of software than defining a static image. And if it was my priority to have all of them look similar, more similar, then I'd have to be more descriptive in my program in English. So this was Jared's. This was Robert's. Basically what I learned is that I needed to be slightly more descriptive in order to have them be more similar in feel. There's a lot of similarities between mine and Jared's, but in the other two not. This one's Williams. And then, yeah, so that's that project. And then all, like the code for all of them, I don't remember which is the code and which is text. Oh, here's the code. Yeah, so the code is all here. And then also one time I did an exploration where I gave the same text to a painter and had them do an image based on this text. And then that was an interesting exploration too. That's the end of my answer to your question.
Do you have the images?
I don't think I have it with me actually. I'm sorry, but I don't. Okay. If anybody has a question, but you're a little bit shy, you can just talk to me after we finish the formal session. Does that seem fine? Should we stop or should we?